In lesson 4, we will be talking about dividing rational numbers. Again, rational number, any number that can be written as a fraction. Dividing rational numbers is basically just like multiplying with one extra step at the beginning. We take our division problem and change it into a multiplication problem by multiplying the reciprocal. Okay, so 1/9 divided by 5/12. You keep your first fraction, we change division into multiplication, then we multiply by the reciprocal. The reciprocal means we're going to flip that second fraction. So 1/9 times 12/5. You may have heard keep, change, flip in the past. That's applying to this, but we want to start using the real vocabulary words. So dividing by a fraction means that we are going to multiply by the reciprocal. Right now, just like last lesson, I like to reduce. 12 and 9 are both divisible by 3, so that leaves us with 3 and 4. Then multiply straight across to get 4/15. So 4/15 is our final answer. That does not reduce any further. 3/7 divided by 8. In order to think about the reciprocal, we need to think about our whole number as a fraction. So 8 we'll rewrite as 8/1. So we're going to keep 3/7, change the multiplication, and then multiply by the reciprocal, which is 1/8. You didn't need parentheses there. I'm actually not sure why I wrote them. So now we check. There's nothing that we can reduce. 3 times 1 is 3. 7 times 8 is 56. Double check again. 3 does not divide into 56. So our final answer is 3/56. Okay, moving along. We're going to keep our 5/8, change division into multiplication. Then our reciprocal of -3/4 would be -4/3. I'm just going to keep that negative in our numerator. Check if we can reduce. I see a 4 and an 8, both divisible by 4. So 5 times -1 gives us -5. Over 2 times 3 gives us 6. 5 and 6 do not reduce, so final answer is -5/6. Now this next one, you must change it into improper fractions first, just like when we did multiplication. So multiply and add. Again, when you multiply, don't think about that negative. So we know we have a negative. 4 times 3 is 12, plus 2 gives us 14/3. Keep division so far. 9 times 3 is 27, plus 1, so 28/9. Now we're going to keep our first, change the multiplication, and then multiply by the reciprocal, so 9/28. I definitely don't want to work with multiplying these numbers. 3 and 9 reduce, both divisible by 3. I see 14 and 28. They're both divisible by 14. So I'm really doing -1 times 3, which is -3, over 1 times 2, which is 2. I don't want to leave it as an improper fraction. I want to change that to a mixed number, which would be -1 1/2. So -1 1/2. Okay, now that we've worked with how to change a division problem into a multiplication problem, we're going to start working with some variables. Same idea. Keep our first fraction, change it to multiplication by taking the reciprocal, so ABC over 15. Now I'm just going to look at my numbers at this point. I see a 5 and a 15. So 5, 15, both divisible by 5. Now if I multiply straight across, 1 times ABC is just ABC over 3 times 3 is 9, AB. Now if we check out our variables, I see I have an A and an A, so we can divide those out. A B and a B, so we divide that B out. And what are we left with? The only thing on the top in our numerator is C. Only thing left in the denominator is 9, so our final answer, C/9. All right, our next one, keep MN over 4 times the reciprocal, which is 8M And to reduce, I see 4 and 8, both divisible by 4, so 1 and 2. Now this time, I see I have an m there and an m on the bottom, so I'm going to go ahead and reduce those m's out now. So 2 times n, 2n, over 1 times 1 is 1. So we can just rewrite that as 2n. You do not need the denominator of 1. If you needed to, you could have had an m here and an m here and then reduced at that point. You can reduce at any point when we're talking about fractions. All right, moving right along. 4ab divided by c times reciprocal of 2c divided by 3a. Okay, well I see I have an a here and an a in my numerator, so my a's can divide out. I have a c in my denominator, c in my numerator, so those can divide out. Now I have a 4 and a 2, but they're both in the numerator, so we cannot reduce those. So 4b times 2, multiply our coefficients of 4 and 2, be 8b over 3. Well, nothing divides into 8 or 3, and I only have 1b in my numerator at this point. So final answer, 8b over 3. And last one like this. Again, keep 3xy divided by yz times the reciprocal of 5 over 6y. Well, if I check out my numbers, I see 3 in the numerator, 6 in the denominator, both divisible by 3, so 1 and 2. I see over here I actually have a y in my numerator denominator, so I can divide those out. Everything else looks good, but we'll double check at the end. X times 5 gives us 5x divided by z times 2 times y gives us 2yz. Oh, we can't reduce 5 and 2. And then I have an x in my numerator, no x is denominator. I have a yz denominator, no yz in my numerator, so none of my variables reduce. I know 5 over 2 looks like it would be an improper fraction, but since we don't know what our variables represent at this point, we're going to leave it as it is. Okay, so now we've done some work reducing our variables. Take a look at some word problems. 4 pieces of wood, each 14 and 5/6 inches long, are required for building a frame. If all 4 pieces are cut from one board, how long should the board be to the nearest whole foot? So we have 14 and 5/6 inches for each piece. I want 4 pieces from the same board. And then at the very end, I'm going to highlight this to the nearest whole foot. Notice we're currently working in inches. So first off, if I have 4 pieces that are 14 and 5/6 inches long, I want 4 of them, so we're going to multiply by 4. Change this into an improper fraction by multiplying and adding. Gives us 89 over 6 times 4 over 1. I apologize, guys, there's not a ton of room for this problem. So I'm definitely going to reduce at this point. I see 4 and 6, both divisible by 2. So 2 and 3. Okay, so multiply across. 89 times 2 is 178 divided by 3 times 1 is 3. Now at this point, I'm going to change this into a mixed number. It's currently an improper fraction. We want a mixed number. So we know, or if you do division, we'll see that 3 goes into 178 59 times with a remainder of 1. So 59 and 1/3 inches. I want to find out how many feet that is. So if we took that divided by 12. Actually, I'm going to go back a couple steps here. 178 thirds. We know that this is inches. So 178 divided by 12. We're going to keep 178 over 3 times 1 over 12. Remember, 12 will be over 1. Okay, so 178 is not divisible by 12, but if we're thinking reducing, it is even. So we can divide both of them by 2. Gives us a 6 here and an 89 here. Just to give us some smaller numbers to work with. 89 times 1 over 3 times 6 is 18. So 89 divided by 18 gives us 4.9 floor repeating, but we want the nearest whole foot. So we need to round this up because we need to have enough of the board. So we need 5 feet as our final answer. So that one was a little tricky, a couple different steps, and we had to really read directions to make sure we fully answered the question. All right, last problem, 2 parts. Charlie's making croissants. His recipe calls for 2 3/4 cups of butter. He has 12.5 cups of butter. Explain a method for determining the number of batches of the croissant recipe Charlie can make, then use your method to find the number of batches he can make. Well, our method would be, we can divide. So there's our method. And now we're going to actually do it. So 12.5 divided by 2 3/4. Again, changes into mixed numbers. 25 halves divided by 11/4. I'm going to pop up here. 25 halves times 4 11ths. We're going to reduce. 50 over 11. We can't quite make 5 batches. 11 doesn't go into 50 quite enough times for 5. So our final answer would be 4 batches. Can't make part of a batch, so you had to have that whole 11. And then part B, if Charlie plans to make 5 batches of the croissant method or croissant recipe, use what you know about operating with rational numbers to predict the amount of butter he needs, then justify your prediction. Well, if I want to predict, I don't need an exact number. So if I think about 2 3/4, this is approximately 3 cups. Approximately 3 cups for each batch. Well, if I'm making 5 batches, then 3 times 5 would be 15, so we need approximately 15 cups. So there's our prediction. Now we want to justify our prediction. We're going to actually multiply it out. So 2 3/4 times 5. Again, change it to improper, so 11/4 times 5 over 1 gives us 55 over 4. Change that into a mixed number, which is 13 3/4 cup. So we actually need 13 3/4 cup, because if we check back here, our prediction was pretty close. All right, there is lesson 4.